Alright, today we're looking at Chapter 1, Lesson 9 in Glencoe Course 2, which is on direct variation. The book says that direct variation is when two variable quantities have a constant ratio. Well, we know other things that also have a constant ratio. What are they? What's another way that we can say that we have two things in a constant ratio? Raise a hand. Yes, ma'am. Slope. Okay. Is there another one? Constant rate of change. So, we are looking for a situation that has a slope or a unit rate or a constant rate of change. And when we have those things, we call it something that starts with a P. Proportional, thank you. So we are looking at proportional relationships in a slightly different way. That constant ratio is a constant of variation, which is the constant of proportionality. Now, the difference between the constant of proportionality and the way that we write the other versions of this is that this we write as an equation. And we use the following equation. Y equals Kx. Y is our Y value. K is the constant of proportionality. And X is our X value. Now, in our problem, in the examples that were given and what we are asked to find, one of two things may happen. The first thing that may happen is that we are given the constant of proportionality in a situation as a number, and we have to figure out what that represents. Or we will be given X values, we will be given Y values, and we will be asked to find the constant of proportionality. So it works both ways. It works both ways. Let's look in our book. Page 82, example 1. On page 82, example 1, we have a graph. And that graph is looking at the height of water as the pool is being filled. We are asked to determine the rate in inches per minute. So it wants to know in each minute how much water is going into the pool. How much more depth are we getting in the pool? So here I see that I have a proportional graph because the graph is increasing. It's a straight line and it goes through the origin 0, 0. Which means that I can find the unit rate, which is the slope, which is the constant of proportionality. I'm going to look at the point 5, 2. And that point 5, 2, which value is the X value? And the point 5, 2. Which number, let's raise a hand. And the point 5, 2, which value is my X value? Yes. 2. Not quite. Okay, so in an ordered pair, we know that we write an ordered pair as X, comma Y. To find the constant of proportionality, or K, we're going to take the Y value divided by the X. So, in this instance, we have the point 5, 2. Which number goes on top as our Y value? 2. The 2. The Y value, so the second one goes on top. Which one's my X?
5.
The 5. Good. 2, 5 is my what? Which is also called the
Proportional.
The constant of proportionality, which we use variable k for? How can I write that as an equation? Am I substituting anything for y? No. Am I substituting k?
Yes.
What goes in that spot? Just 2? 2/5. Am I substituting anything for x?
No.
So could I write my answer asking me for an equation that gives me the constant of proportionality and the rate of how fast this pool is being filled as y equals 2/5 x? Yes. In our book went ahead and did the division, and it gave me the answer as a decimal. Do we have to convert to a decimal? No. If we have a situation where the points that were given in a graph give us a proper fraction, we can leave our answer as a fraction to make our lives easier. We can divide it and it means the same thing. They're equal. The answer is just written in a different form. Are there any questions about example 1? No. Very good. Thank you. Let's look next at example 2. Example 2 is a little bit different. In example 2, it says that the equation y equals 10x represents the amount of money y Julio earns for x hours of work. Identify the constant of proportionality and explain what it represents in the situation. So, we start with y equals kx. It tells us that the problem is y equals 10x. What does the y stand for?
Right.
What?
The cost.
What value? I'm sorry, let's raise a hand so I can hear. Yes. Y does not equal 10. What does y represent? I'm looking for words or a series of words or a phrase. What does the y represent? Yes, ma'am. The amount of money. Okay? So y is equal to the total earned. That's the total earned. What does the x represent? Because that was also given to us in our problem. Yes, sir.
Hours worked.
Hours worked. What do we multiply by the number of hours worked to get the total earned? We multiply by 10. What does that 10 mean? Yes.
How many hours you work less for total earned?
Not quite. Let's say that we became a bagger at Food Lion. Okay? You work 6 hours, you get paid $60.
That ain't bad.
How did you work 6 hours, you get paid $60? What does that 10 tell us?
$10 per hour.
$10 per hour. So then what does the 10 represent?
Hour per earned. Per money. Per money earned.
What?
Okay, so thank you. So the 10 here represents the amount earned per hour. The 10 represents the amount of money earned per hour. So if you are looking to get a job in a couple years, at the top of the job application forms, most places will ask you for the desired salary. That means how much money do you want to earn for doing that job? Now, within reason, you have to how much money you think your time is worth. Okay? For the majority of us, first jobs make minimum wage.
What's that?
That means that there is a minimum amount of money that you have to be paid for your work. It's set up by the national government.
How much is it?
Okay? Last I checked, it was $8.25. That means that you have to earn at least $8.25 an hour. Last I checked, it could change. It could have changed. But that's that value right here. So when you're figuring out how much your paycheck should be before taxes, because as you're going to have to pay taxes, it's one of those things that you have to do. It,